Pure functions and immutable objects, a quite hot topic. Let's see. So I'm Victor, I'm a Java champion, and I'm deeply in love with simple design, refactoring, and unit testing. 2 years ago, to have a place where to share my love for these, I founded a community, which is today one of the largest developer communities in Romania. Feel free to join. Also, I spoke in many conferences until now, and I compiled for you a playlist that you can find on my website. In April, I gave up my role as the lead architect at IBM, and I am now fully independent trainer and consultant. Now, I gave my first training 8 years ago. And since then, I talked to thousands of developers, hundreds of teams, dozens of companies. Of course, my comfort zone is the Java stack, okay, the typical Java development stack, Spring Hibernate and Java 8. But the most wanted part of my training is actually that doesn't have anything to do with the language, right? It's design patterns, clean code, and unit testing. And I can do this in many languages. Recently, ReactiveX and Java performance were more and more demanded. Now, if you want more details about training for you or for your company, there's my website. Check it out. It's all there. The detailed agenda, everything. Now, I'm also on the social media, and if you care to reach out to me, Twitter is the best, but I'm also posting on other social platforms. Good. Let's start. Let's start with life. How is life? Let's see. Okay. Have you ever had a code in which you wanted to invert, to swap two lines, to move it up, and then you had a bug? You didn't understand why it happened. By the way, that's called the temporal coupling, when the order of two instructions matter. It might surprise you, and I'm sure you were annoyed when this bug happened. Have you ever had a method that changed the parameter? And when kaboom, I changed it like this. Okay, hey, customer set active true. My God. Have you ever do you ever had to mock 7 dependencies in order to test some functionality? Did you ever had a race bug? Childhood ends when you have your first race bug. Or did you ever had a function that you called 2 times or 3 times and it gave you different results from the same inputs and you didn't expect that? All of this talk today is about these problems, really. Now, 26 years ago, Bertrand Meyer wanted to separate functions in commands and queries. Now, a command function will return you void. Now, tell me, why would you call a function that gives you void? Well, I'm sure not for the result. Okay, it's void. So you will definitely expect something to happen, some side effects to happen when you call a void function. Now, a query, in contrast, it gives you a result. Now, I'm sure no developer expects that when you search something, a row is inserted in a table. Or if you compute the price of a movie, you get different results the second time you call it. So typically, most developers, when they see a method giving them results, they will expect these are pure functions. Now, a pure function is a function that is not allowed to do any side effects. You aren't allowed to insert rows, to issue posts, say, over HTTP, to send messages or write files, or even change fields. Oh, and by the way, logging doesn't count. Doesn't matter. This is not business relevant. Now, besides that, a pure function will give you the same result if it's given the same arguments. In other words, you should not rely on current time, on random, or even a get over network, or even a query in the database might give you different results the second time you call it. Okay, so these are, you should avoid doing this. Now, a function giving you the same results for its argument, it's called referential transparent, if you want to use the geek word, okay? The simplest example of a pure function is the mathematical function, right? Mathematical functions don't change anything in the world when they are called, and they give you the same results if you give them the same inputs, okay? Now, to make sure we understand, let's do a little quiz, and I want you all to think for yourselves. If f1 takes x as a parameter, x plus 1, is this a pure function? Well, no side effects, the same results every time for the same x. Okay, that's a pure function. How about this one? What the heck is that? It's incrementing the x field of d and then returning it. Clearly, it changes the field. So it does side effects. That's why this is not a pure function. How about this one? You increment x and then return d dot x. Well, increment x, by its name, you kind of expect it changes stuff, right? And if increment produces side effects, also f3 will produce side effects. So f3 is not pure. Nice. How about this one? Well, I just told you, querying the database is not pure. Why? Because it can give you different results if someone just committed an insert between the two selects, right? Oh, how about this? This dot x plus y. Let's think a bit. So it uses the parameter for sure, but it also uses the field of the current instance. This is tricky because the question that you need to ask yourself is, can x change on an instance? I mean, is this immutable? If the class that holds the f5 is immutable, if x cannot change between two invocations of f5, then calling it again with the same y, will get you back the same results. The trick happens when x is mutable. That's why people out there typically think of pure functions in a static context. If you think of it like that, this function really has two inputs, this one, and that coming from the instance in which the function is. So again, if this is immutable, f5 is pure. Nice. How about this one? It gets data as in and y and adds them together. Well, if you think of it, it doesn't do side effects. But the question is, will it give you the same results for the same inputs? And you might make a parallel to the previous example, and you might think, wait a second, D might change. But I will answer, okay, wait, but if D changes, the second time you call the function, you technically give a different D with different values. So this function is pure because it only draws data from the inputs. Okay. Now, again, we kind of expected get to be pure, but if get changed something, now you will probably scream. So getter should always be pure. Okay. Don't change stuff in the getter. That would be outrageous. Okay. So names matter. Names matter. Now, is this pure? If I is less than 0, then I will throw exception. Exceptions? What do you mean exception? Yeah, but wait a second. Interesting. Throwing. Well, exception is the sort of result, right? So this is also pure. Technically speaking, throwing an exception is pure if you throw the exception consistently for the same inputs every time. Nice. Nice. Catching exception, is this pure? Well, let's think of it. If you have this try block over here, if you catch an exception, will this function be pure? It depends. It depends on the exception. If the exception that you catch is consistently thrown from the try block here based on the input. So if it's given the same input, if given the same input throws the same exception, then catching the exception here is safe, is pure. But if you catch exceptions that can happen randomly, like IO exception or out of memory, then you don't depend just on inputs. You depend on surrounding state, like writes on folders or memory state. So this is not pure. This will make your function impure. And that's another reason why you should catch exceptions in the outskirts, in the boundaries of your code, okay? Not in the middle one. In the core logic, you should not do try catch on unexpected exceptions. Nice. So why do we love pure functions? Because they don't rely on any hidden inputs. They only use plain sight parameters and return values. Okay, simple as that. You give a parameter, you get a result. Nothing fancy, nothing hidden. That's why they are easier to understand and easier to test. You don't need to mock a lot of dependencies. You just pass parameters, it takes results. Beautiful. They are also typically very fast because they aren't allowed to work with outside worlds. Okay, so they are fast typically, and they are easy to compose because you don't need to be afraid of any order. They are pure. The order doesn't matter. Call them as you please. So play very nice with Java 8 on this one. They are very easy and very safe to run in parallel because since they don't change anything, they can safely run simultaneously on multiple threads. Nice. So a lot of advantages over there. So I convinced you, right? From now on, you will only use pure functions everywhere. That won't work. I mean, just think of it. What kind of an application won't change anything in the world? You need to change something, right? Now, to start with the bad news in Java, there is no way to strictly enforce purity. You can't ask the compiler to do that, nor the runtime. So you have to live with both pure and impure functions. And the question is, how do you distinguish between them? Because it's essential to know if a function is pure. If it's pure, you can call it as many times you like without breaking anything. Okay. So you have to distinguish between them. You might think of that separation that we discussed previously, okay? Command query. But in practice, this proves to be very hard to follow. There will be times in which you will have a method that has to do some inserts, but it also needs to return values. Now, one workaround to this is to have a name which expresses the fact that you don't only just compute the price, but you also adjust the metrics such that the next time you compute the price, you might take into account that you've asked the price previously, just like in low-cost airlines, right? If you book a flight twice, you might get a different price second time for the same flight. So one way to work around this is to highlight the side effects, the danger in your code. But I'm sure you can do better than that. Let me sketch a design for you. Imagine you have this complex logic in your application. I mean huge, hundreds of lines of logic. I want you to isolate in the middle of that logic a functional core composed only of pure functions, leaving outside a surrounding imperative shell. That imperative shell will do all the dirty work, and you will push those side effects and reads from outside world in the imperative shell, leaving the functional pure. Whoa. So I mean, expose impurity, expose reads, writes, changes, expose them in plain sight. Okay, so purify, and then purify the more complex part of your logic. The middle of your functionality should be pure function. How do we do that? Just to get one thing out of our heads, don't care about time and random. Just trust me on that. Don't care. If a function relies on time or random, you don't really usually need to care about that. So it can still consider it to be pure. Very rarely you really take decision based on current time. You just typically just put a creation date and something like that. Now, again, to state the obvious, you should not use files in the functional core because files are a source of chaos. Who knows what's on the disk? Can change, can have IO exception, whatever. So don't call files. Now, the real struggle is the reads and writes from external sources, from database or other APIs. That's where the pain is. Now, if you are lucky, then you might only need to read data at the beginning of a workflow, in which case you can read it in the imperative shell and then pass the data to the functional core. Very easy. Typically, at the end of a workflow, you will persist some results somewhere or do some side effects. Well, my advice is to return those side effects or those things to change out in the imperative shell, and there you will perform those changes. Whoa. But that's not the hard part. The hard part is what happens in case you have a long function which does an intermediary read or access to an external data source. Then what happens? Well, it's ugly because it's in the middle of a function. It happens all the time in legacy code. What do? There is a very interesting refactoring for you. It's called split phase. What it wants you to do is to break that functionality into two little pure functions, call those two separately, and expose the impurity at the top level in the imperative shell. Now, what's the main trick of this refactoring, however, is what's here. What's here? What is the necessary data to pass between the two phases of your processing? Very interesting refactoring. I'm debating it a lot I talked yesterday in my refactoring training. So my point here is that you should implement as much logic as pure functions, exposing impurity to the surface, exposing the danger to the surface. And this gets us to the most tricky part, really. What happens if you want to change the state of an object in the middle of your workflow, deep inside your workflow, 7 layers deep, in a function called 7 layers deep? Well, there is no possible way to enforce that you don't change anything unless you are using immutable objects. And this is how we get to immutable objects. But again, I want to clearly state the problem. So imagine you are in real production, heavy production life, okay? And you are inspecting the code, not breakpointing, inspecting. And you want to figure out by looking at the code whether this line will run or not. To figure this out, you need to find out what's the value of X. So you will trace where data came from. It came from G. And then in turn, that one came from H, you see? And basically the instance here came from H. Now, in H, you gave X the value 1. Okay, but now let's see what happens if data is a mutable class. Well, of course, somewhere along the road, someone could change X, could change X, right? Could change X. And this is very strange. You need to look out for anywhere. But there is a more evil way. There is a more dangerous situation in which you pass the data to another function and that function changes your object. This is evil, but happens all the time. It happens all the time, right? Maybe there are even 7 methods deep, and then somewhere in the corner, someone updates X. Very often this one happens in production. Okay, but you know what? There is an even worse example, an even more evil example, in which you call a function without giving it any parameter. But it happens that this function has access to a reference of the same instance. Where did it get the same reference? It got it from before, from previously. So it got it from here. It put it on a field, and on that field it changed the x because the object from here ended up here. I agree this is not a very common situation, but it's incredibly horror. Okay, I mean, using a reference you kept from beforehand from several minutes ago. This is just insane. This is hell. This is hell. The bottom line of this example is that long-lived mutable data is bad. It's classic code smell. Global mutable data is madness. But long-lived mutable data is also very evil. I mean, if that instance goes through hundreds of lines of code, that there will be in a corner someone thinking, oh, let's change this field. Okay, so basically, what we need to detect, if you want to determine whether this line runs or not, is you have to check all the code that ran before this line, having a reference to my data instance everywhere. Okay, you will have to look at every other possible method call that happened before you. Now, let's happen if this were immutable data. If this is immutable data, you don't have setters, right? You can't change anything. If you don't have setters, you don't need to look at all the other places, at all the methods that you give a reference to your object anymore. You don't care. You give it a reference. So what? You can't change it anyway. So clearing up the clutter, what you end up with is this. Tracing where the data came from is just a matter of finding who created this instance. Way more easier. Logarithmically is less space to search than looking at all the places that ever ran before you. Okay, that's why we love immutable. That's why they are most valuable, because they made it very easy to trace the data changes. Okay, and in the real world, there can be many methods in between. Okay. But then let's try to design an immutable. I was planning to write code with you today, but since I have so much to tell you, I decided to put on a slide the things that I wanted to write in code. So classically, an immutable object, we all know it should have final fields, but you do realize this is not strictly required, right? If you don't have the setters, then you can't change the fields anyway. So, but still, final is classical, we will put it there. Now, if you have a reference to B, you should make sure that B is also immutable. Otherwise, you will get shallow immutability, not deep immutability. Because now a fully immutable A will have B also to be immutable. Okay. Now, since they are final fields, you need to take them to the constructor. There you go. And then you might find out a weird thing. You might need to clone the array list here. Why? Because the creator of this object might keep a reference to this list and might mutate the list after you've put it in your field, effectively mutating your list within you. Right? Oh, but this is insane. This is a waste of memory, first of all, but fortunately, this I believe is overkill, because the problem is not who created A, but the man in the middle. Remember, those the places through which the data object passed through. The problem is not just here; is the 10 methods in between. So although this by the book is necessary, in many cases is not strictly required. Now, if you have an immutable class, you will get a lot of benefit if you validate the state of that object right in the constructor. This will get you to what we call the self-validating data model. It's a very powerful technique, gets you to a more robust data model, but it might hurt you a bit in unit tests, because you can't possibly create in partial instances anymore. You need to fully populate valid objects. Okay, but what's next? Well, we need to get the list out of that. If you get the list, you need to wrap it in a decorator, which will block every attempt to change the list. Otherwise, a caller might get your internal list and might mutate it, right? Do list.clear and destroy your list inside. So this is, again, pretty classic. Now, there will be getters and setters. Oh, there is another form. You should think of these also. You might think of returning an iterable. This will allow your callers to iterate over that collection, but they won't allow them to add. There is no add method in this interface. This is a trick, right? You make the compilation break if they attempt to add. You don't rely on runtime checks, on runtime exceptions. Oh, and there's one homework for you. Try this one. Just try this one. Just try and see what happens. You'll have a surprise. Okay, there will be other getters out there, and there will be probably hash code equals. And if you are strong enough, you could put also some logic in those little objects, but not big amount of logic. Several lines of rules that you can work out based on the fields of this object. Not so many logic, because otherwise you will need to mock that in some cases. You don't want that. So small, safe, strong logic inside these classes. Okay, now I've discussed about immutable objects with hundreds, thousands of people, and hundreds. And the thing is, I was told that I need to make it final. I don't need that, really. Now, if you, as Trisha said previously, if you wait until September next year, you might jump on the Java 17 long-term support, and then you could use records, which get you final fields, constructors, getters, headers, hash code equals, and toString for free. But until then, you can resign yourself with Lombok. Okay. Now, how do we change such an object? Oh, in final? Yeah, final is not useful. I told you. Final? Why putting it final? Are you afraid of your colleagues? Do you think someone will hack your class? Don't your colleagues know that we never subclass concrete classes? Who are you afraid of? And even if they subclass you, what can they do? Anyway, so, then your object might need to change. How would you change an object that is immutable? The only way to change it is constructing another object, okay? With S, constructing A, changing S, and keeping the previous values there, okay? So you can mutate these classes by creating new instances. But this allows you basically a way in which you can change stuff in an immutable object. And you might get ideas then. Wait a second, I can do this. I can, every time a function needs to change data, it could return the data back. Oh, okay, so I'll do this every time. Excellent, excellent. Now imagine that this class has 20 fields. And you want to find out at the end who changed the X. Who let the dogs out? Who changed X, you know? And you have to hunt down in every such method and find out who the heck changed the X, right? It's insane. So the mess is still there. That's why this is a bad practice. Returning back the data when you changed it, it's better still, but you can do better than that. You can do better than that because you could enforce final variables. That's a brutal way to fix that. This won't compile anymore if the data variable is final. Now, in my personal preference, I would rely on the little underline which IntelliJ puts under variables which are reassigned. I know I'm relying on a tool. I know. But you know, in legacy code, in old code bases, there might be cases in which, you want to know the variables which change throughout the function. So look out for this underline. It helps you a lot. Okay. So then how can we do this better, really? The real problem that you're facing here is that you have two large immutable objects. An immutable object shouldn't be 30 fields. A mutable entity, a mutable object is very often has 20, 30 fields. Okay, but an immutable object, it's insane. You will have to do this to change those fields. Well, my suggestion here is to break them. If you wanted to change X, Y, and Z, what you can do is to create a little object which contains X, Y, and Z, you know, and have the function return these three, not changing fields one after the other. The principle is that if they change together, they stick together. So don't be afraid of creating new abstractions, new little objects, immutable ones. But this guy has another idea. And I'm really afraid to show you this slide. Who in the world would do that? Or this? Can you imagine this? You get a list and you remove elements from it. What the heck? Or even worse, you get an element from a map, right? You get the value 1 from the map, and then you mutate it, and then you put it back in the map. Who the heck would do this? Who the heck would mutate? Don't ever mutate collections. Create new ones. Because Java has this weakness. It's an old language, 25 years old. Back in the days, they didn't thought about this. The collection framework in Java, they are all mutable stuff. So don't mutate collections. There is no strong defense. Clojure solved it elegantly. They have brilliant immutable collection framework, but for us in Java. Then let's summarize. Why do we love immutable objects? Because they are easier to trace where they changed. Because you can enforce very easy validation in their constructor. They are more robust in a sense. I didn't show you why they are safe to put in maps and sets. That's for another talk. And they are also thread safe because you can't possibly produce bugs because, okay, it's readable, it's immutable data, immutable, read only. Okay, go ahead, read. You want to read from 20 threads, go ahead, read. Nothing can go wrong. So I convinced you, right? From now on, you'll only use immutable objects. Stop. No, that's too much for most applications. For 99% of applications, that's too much. To get you to the real explanation, I want to introduce for you another concept here. Let's imagine you have two classes, money and customer. Money has amount and currency, and customer has ID, which is a primary key in the database, name and phone. How would you implement equals on these two classes? But on money, for certain, I mean, you will compare each field in turn, right, to test whether two instances are equal. But for customer, if you get two instances of customer, even if they are dramatically different, if they have the same primary key, the same ID, then it means it's the same customer. That's the difference between a value object and a reference object. A value object, you will implement equals based on all the fields. And I would advise that all value objects in your application should be final every time. So all of these you would make final. But how about the other ones? How about your entities? That's the question. Should your entities be immutable? No. No, it's too much. For most applications, it's too much. But what would I advise you instead is to extract immutable value objects from them. Take little bits of data that stick together and take them out of your entities, leaving the root entity mutable. And that's how you use immutable objects in real life. You have the root mutable entity and the persistent leaf that you can, like full name, like tracking info. And it will be a continuous effort to take stuff from your large entity into little objects, immutable objects that play very nice. Oh, and if you are on Hibernate and wondering if this is possible for you, yeah, it is. Read about Embeddable and follow me on, I will be talking about this soon. So, yeah. But there is another flavor of immutable objects. There are the runtime objects. Those that don't get persisted, are just there in your workflow doing stuff throughout your business logic. All the objects that you manipulate during runtime in your business logic should be immutable every time. Why? Because that's the big deal. Now, don't mutate objects on long workflow here. Instead, return the change to the surface. Here, this is the change, and apply the change there at the surface. This would allow you to have these pure functions, right? Because they don't change anything anymore. They just return. Now, there is a trick here. The thing that you get in those methods should be immutable to make sure you don't change anything. And there is yet another challenge that you will face. How can you change different fields, multiple fields at once? Right? You could use a tuple, or even better, you can search for a new value object to represent what those string integer meant. Okay, and this will enrich your entity model. Okay, so the big deal with immutable objects is that is when they travel a lot of code. That's when they pay off. That's when they are most valuable. Oh, people ask me about performance. Ooh. My advice as usual is to measure, and you will have a surprise because immutable objects, they are little objects, I told you. These are no problem for the garbage collector, but still there are some tricks here. If you do trash millions of instances per second, that will annoy garbage collector. Or if you clone lists a lot, right? Because you will find that to add an element to a list in Java, you need to clone the array if you want immutable objects. But this is a waste of memory, and arrays are a pain for garbage collector. They are contiguous blocks of memory. So if immutable objects containing lists are a bit dubious in Java, I would say. Trivial logic. It's overkill. Why immutable objects? If you just have an object going through 5 lines of code, who cares? Or 20 lines of code, who cares? The catch is for long workflows. And entities, don't struggle to make the full entity model immutable. Doesn't pay off. Okay, wrap up. What did we learn? Every time, so I want this to be a reflex for you. Every time you are facing some complex logic, you are about to implement some weird, complex business rules, think of implementing them as pure functions using immutable objects. And then put them in your functional core and push anything which is impure in the imperative shell surrounding your function. Now, as a mindset, don't change stuff inside. Compute and return. Do you feel that? Don't change it there in the middle. Compute and return. And again, we saw this guy. Without proper mindset, immutability can hurt your code, can make it worse. And don't ever mutate the arguments that you get, the variables. Don't reassign variables, and don't mutate collections that you get as a parameter. This is just evil. And in immutable objects are basically useful in 2 places, in which you have runtime data that moves through your business logic, or those little persistent leaves in your entity model. And you can convince the ORM to do it for you. Now, I'm not against object-oriented programming. If you think I've said that, hunt me down in the chat space just now. There are places for OOP, but what I've showed you here is how to implement long, complex functionality, right, in an elegant, safe way. And if you take something from this talk, this is it. Don't change stuff in there. Compute and return. And with that, I'm done. Thank you so much. I'll be heading to the chat space now, right?
Hello. Yes, your talk was really, really amazing, and it was like active. You were very active. Like personally, I was like so into the talk that I forgot that I'm really have other duties to do. There are really interesting questions in the chat. I will be giving you only one of them, and people can still join special chat and have more like ask you more about it. Okay, so there is this question from Cyril. He's asking if a question is internally doing memorization, is it still pure? I guess so. Same
memorization?
Input, same output. Yes.
Okay, memorization is a sort of a cache. Memorization is memorization is cache for pure functions. Now, you have to realize a pure function will give you a result. Can you see my screen still? Yes. A pure function will give you a result for some inputs. Now, unlike a normal cache, the problem with caches typically is that caches can get stale, can contain invalid data, right? Normally, if you cache something from the database might change and you might get obsolete data here. Now, memorization means to cache the results of a pure function. Now, a pure function, pay attention, will always give you the same result when you give it the same inputs, right? So technically speaking, if you cache this result, this cache can never go stale. I repeat, can never go stale because F12 will always turn 3. So memorization, a pure function, is still pure. Memorization of pure function is still pure but the trick is just a matter of efficiency. In normal life, you will almost never use memorization. The pure functions are so fast by themselves. What kind of computation would you do in a pure function that is so heavy? What do you do? Encryption? What do you do? Hashing, memorization, or evaluating chessboards? What are you doing? But memorization, if you have a CPU intensive, heavy pure function, memorizing that will still leave the code pure. But as any cache in the world, what you cached can be evicted in low memory conditions. But this will not change anything because the function will run again and it will give you the same results. Very good question, incredible question. So yes, excellent. The memorization is still pure.